In this presentation, we're going to talk about the specific application of ammonium sulphate. The contents of this presentation is firstly crop requirements, then the composition of ammonium sulphate, conversion processes in the soil, the potential losses, that is leaching and volatilization, conditions of preference for ammonium sulphate, unique characteristics, specific applications, contraindications for the use of ammonium sulphate. Firstly then, crop requirements. Crops would prefer nitrate N to ammonium N, according to this slide. But that is if we look at the two sources separately. In fact, crops prefer a combination of the two. Most ideally, 3 parts of nitrate N and 1 part of ammonium N, that is 75% nitrate N and 25% ammonium N, would be the ideal. This was proved to be the case under field conditions in a rather dry area like Viljoenskroon, but also the wetter part of our country like Dundee in KZN, exactly the same. Where only ammonium sulphate was applied and not allowed to be converted, it was not the ideal situation. Then crops also need sulphur. In this table, we've got a summary of the most important crops as far as sulphur removal is concerned. Firstly, on top, groundnuts will remove 3 kilograms of S per ton of groundnuts. That implies a requirement of 9 kgs of S for 3 tons of yield, and so on and so forth for the other crops. Ammonium sulphate contains 21% ammonium N and 24% sulphate S. Both these forms can be taken up by crops, but as we've said, about 75% of the ammonium N from ammonium sulphate should ideally be converted to nitrate. In the soil, when ammonium sulphate dissolves in the water in the soil, you have 100% ammonium N at first, then bacteria will convert the ammonium to nitrite. Firstly, the nitrosomonas bacteria would be responsible for that, and then the nitrobacter bacteria will change the nitrite to nitrate. This process is called nitrification, and the nitrification process will be affected by the ammonium N concentration, the pH of the soil, the aeration of the soil, and also the temperature of the soil. In this slide, we are showing potential losses of different nitrogen sources. Firstly, ammonium sulphate. When applied on the surface of the soil at the zeros there, will remain in that top 5 centimeters of the soil when water is added to the soil and when the water penetrates the soil to a depth of 22.5 centimeters. While in the case of urea, urea will follow the water to the same depth. In this case of calcium nitrate, the nitrate will also follow the water to the same level of water penetration. In this slide, we have potential losses in terms of volatilization. We have a comparison of several nitrogen sources where the different sources was applied on the soil and then incorporated into the soil. and then water was added to these different soils. In fact, what we're seeing here is an average of 7 different soils. Firstly, I want to talk about ammonium sulphate, which we see over here. We notice a 10% volatilization loss for ammonium sulphate compared to about 18% volatilization loss for LAN and roughly about 40% volatilization loss for urea. This slide is also about volatilization losses, but at different pHs. The effect of pH on volatilization is rather important, as you can see in this slide. We have pHs ranging from 6.5, that's a water pH, to 9.1. And for all N sources, LAN, ammonium sulphate, urea, and the others, we have an increase in volatilization losses with an increase in pH. For these sources, the volatilization loss with an increase in pH is much more for urea compared to ammonium sulphate. But then on the other hand, the losses from LAN is less than from ammonium sulphate. In this specific slide, we have conditions where ammonium sulphate showed higher grain yields for wheat compared to LAN or urea. What are these conditions? I've summarized them in the green box on the slide. Firstly, it's a Hutton soil, which was sandy, 9.3% clay to a depth of 750 millimeters, which means it's a well-drained soil. N sources were spread broadcast on the surface and soil incorporated, and then water was added under irrigation conditions. The results from these treatments were higher yields in the case of ammonium sulphate compared to either of the other two, namely LAN or urea. And what could be the reasons for this effect? Firstly, we say we had less leaching with ammonium sulphate. Secondly, we also supply a lot of sulfur together with the nitrogen when we use ammonium sulphate. I've pointed this out on the slide. The N rate was 140 kgs of N per hectare, and in the case of ammonium sulphate, also 160 kgs of S per hectare. Now, what are the unique characteristics of ammonium sulphate? It's an important source of ammonium, nitrogen, as well as sulphate S. It leaches less than any other N source. Volatilization is relatively low, but can be significant when the pH of the soil is high. It's more acidifying than any other N source per unit of nitrogen. To illustrate that, you need 5.2 kilograms of pure calcium carbonate to neutralize the acidifying effect from ammonium sulphate nitrogen. In comparison, you need 1.4 in the case of LAN and 1.8 in the case of urea. Ammonium sulphate will also displace an excess of sodium, which is rather important under alkaline conditions with high sodium content. Then the soil, of course, must be well drained. Another use for ammonium sulphate is an additive to glyphosate herbicides because it will improve the efficacy of these herbicides. What are the specific applications of ammonium sulphate? Firstly, as a pre-plant application, it can be used on well-drained soils, high pH soils, where we want to increase the mineralization tempo of organic material in the soil, when we want to rectify S deficiencies, when we want to displace sodium, when it's in excess. And then at planting, it can be incorporated into plant mixtures. In that respect, it will decrease the leaching of the nitrogen in the plant mixture. It will also supplement the sulfur content and supply some of the requirements for the crop. After planting, it can be broadcasted and soil incorporated. It can also be combined with other N sources like LAN in a product that we call CANAS, or ASN, which stands for ammonium sulphate nitrate, either as a granular or as a liquid. Then it can also be used together with herbicides to increase the efficacy of glyphosate herbicides. What are the conditions under which ammonium sulphate should not be recommended? Firstly, banned placement of large quantities. The nitrification process cannot take place under these conditions, and that will result in ammonium toxicity effects on crops. Therefore, this should not be done. Secondly, surface applications on high pH soils, which is not soil incorporated. This practice will result in ammonium volatilization losses, which therefore can also not be recommended. In summary then, what are the most important aspects of ammonium sulphate that we should remember? Firstly, ammonium sulphate should be used in combination with other N sources rather than to use it on its own. In combination with other N sources, it will definitely decrease potential leaching losses as well as volatilization losses. It's also a very important source of sulfur, and it should, in many instances, increase the efficacy of nitrogen. Well, folks, that is what I intended to bring across to you. I hope that this covers most of the aspects of the use of ammonium sulphate. But you may have other questions, and if so, please feel free to contact me. Thank you very much.